Good day friends, CEV welcomes you for watching this video. Please do not forget to like, comment and subscribe our YouTube channel Registered Values Club for getting all new professional updates. In this video we will discuss about foundation excavation process, how its quantity is estimated and what are the CPWD rates which are applicable for foundation excavation process for different activities of foundation excavation process. So foundation excavation, it forms a critical first step in any construction project, setting the stage for structural integrity and project success. This presentation explores the complete process of foundation excavation, techniques for accurate quantity estimation, and standardized TPWD rates that guides costing in India. So understanding these elements is essential for engineers, contractors, project managers, supervisors, or anyone which is associated with this construction work, seeking to ensure both structural safety and cost control throughout the construction life cycle. You know, it is a base which is foundation of any structure on which for the whole structure rests, and foundation excavation is the base of the foundation over which the foundation will rest. So it is important to have the foundation laid on a soil which has the capability of bearing the load which is coming from the superstructure part. So we will discuss about all the things which are involved in the foundation excavation process. What are the things which are needed? What is the mean by foundation excavation in this video. So first of all, we will discuss about what is foundation excavation. You know, for laying down of the foundation, you need to excavate the foundation as per the requirement. So it is the systematic removal of soil, rock, and other materials to create space for construction of footings and foundations. The critical step is in the construction sequence ensures that the building's foundation rests on suitable bearing strata with adequate load bearing capacity. The process involves precision engineering to achieve proper depth, width, and alignment according to structural specification. Proper excavation not only provides physical space for foundation but also exposes suitable soil layers that can safely bear the structural loads transmitted from the building above the foundation. Without proper foundation excavation, building risk settlement issues, structural failures, and reduced longevity. The excavation phase also provides valuable information about the actual site conditions that may necessitate design adjustments. So it serves a multiple purposes as it removes the unsuitable surface soil that may contain organic matter which may affect the building, and it reaches to the soil layers with appropriate bearing capacity over which the foundation will rest, and it creates space for foundation elements and utilities, and it allows proper drainage system implementation. But before you carry out the process of foundation excavation, you have to make pre-excavation planning in which you have to do site clearance, then you have to establish benchmarks, and then you have to set the boundaries of the building. So inside clearance, as you know, we have already discussed this in the first video. This is the first preparatory step which involves comprehensive clearing of the construction site. All vegetations, debris, roots, and organic matter must be removed to a depth of at least 30 cm below the foundation level. This prevents future decomposition issues and ensures clean working conditions. So after you have completed the site clearance work, you have to establish the benchmark. So basically what are benchmarks? These are a permanent reference points which are established by using a masonry pillars or other suitable structure. So basic purpose of providing benchmark is to provide fixed elevation reference for all subsequent elevations and construction activities, ensuring consistent measurements throughout the project lifestyle, project life cycle. So next, after you have done the or established the benchmark, you have to set the boundaries of the building of which you have to do the construction. So the site parameter and other key control points are then clearly marked and skewed. These boundaries delineate property lines, setbacks, and the footprints of the plant structure, serving as guides for the excavation team to follow during improvement, impl- im- implementation. Implementation. So through the pre-excavation process planning process, it reduces error, minimize rework, and establishes proper documentation for the project. So maybe additionally, this phase include utility identification, soil testing, and coordination with the local authorities to ensure compliance with the regional constructional codes. So after you have done site clearance, you have done benchmark establishment, and you have set the boundaries, then you will set out the foundation layout. So basically in the foundation layout, what we do, first thing is you have to do precise surveying and mark. So setting out is a process of transferring the foundation design from the drawings to the actual ground level. So whatever the drawings you have with you for foundation details, you have to plot these drawings on the site, which is called the setting out process. So for this process, we generally use tidal total stations or steel tapes as per the requirements to establish accurate reference points for that defines the building's position and orientation. So the process begins by marking the main center line of the building. These primary areas serve as reference for all subsequent measurements. Next, the team marks the outer edges of the foundation, columns, positions, and other critical elements. So first of all, you establish the center line of the foundation, and then the outer part of the outer line of the foundation and the column footings are marked. Then for this, we generally use wooden pegs of size 50 millimeter by 50 millimeters, which are driven into the grounds at key points. So brightly colored nylon string is then selected between these pegs to visually represent the foundation trenches, building lines, and other boundaries. So once this has been done, you have to keep and preserve these reference points for future reference. So to ensure that the markings are not lost during Excavation. Permanent reference pillars are constructed beyond the excavation zone. These concrete or masonry pillars contain embedded steel nails for markers that correspond to key building lines. The relationship between these reference points and the building layout is carefully documented in the site sketches and coordinates list. This allows for a quick recheck or re-establishment of the layout if the markings are diluted during construction activities. So once all these lines have been established, then next your aim is to determine the excavation depth. So depth of excavation is very important for any type of construction because it will affect the settlement criteria of the building. So if the proper depth has not been provided, or if the foundation has not been provided at a proper depth where the soil has the requisite bearing capacity of bearing all the load, it will lead to the unequal settlement which may affect the building's life and longevity. So determining excavation depth is very important, and for that you may have to use any of the following three methods. First method is design based determination. So the excavation depth is primarily determined by structural engineering requirements based on the building load and the soil bearing capacity. The foundation must establish soil strata that can adequately support the structural weight and resist settlement. Second, it also depends upon soil investigation. If the soil investigation has been done for calculating the bearing capacity and other criteria, then the depth may be based upon the soil investigation process. So geotechnical reports from the soil footings and tests provides critical data about the subsurface conditions. These investigations identify the depth of suitable bearing strata, potential problems of soil, groundwater levels, and rock formations that might impact excavation. And third is systematic measurements. So maybe during your excavation you find certain things which you have not been able to find during your soil investigation or other process. So depth measurements are maybe changed. For that you have to take depth measurements at regular intervals, typically after every 5 to 10 meters to ensure uniformity. These measurements are referred to the established benchmarks to maintain accurate elevation control throughout the excavation process. So additional factors which may affect the excavation depth includes frost penetration requirements in cold climates and presence of underground utilities, adjacent structures that require protection, and local building code requirements. Continuous verification during excavation is essential as actual soil conditions may differ from the test boards. Next is excavation process. So basically when you do excavation, mostly we use layered digging. So what is layered digging basically? So foundation excavation proceeds in controlled horizontal layers rather than digging straight to the final depth. So this process is called layered digging. Means you dig in layers, not we directly go to the final depth in one stretch. So this layered approach offers several advantages. It maintains Stability of excavation sites allows better control of excavation accuracy, enables identification of soil changes or unexpected obstacles. It facilitates adjustment of plans if required, and it improves safety by creating working. So once you have decided the process of excavation, you need equipment for that. So you may do excavation with the help of mechanical equipments, or you may do it manually, or you may have some hybrid approach in which you may use machines as well as manual both ways. So in mechanical excavation, you need excavators, backhoes, and bulldozers for large projects. And for small projects or in confined areas, we generally use pickaxes, shovels, and wheelbarrows. And in hybrid approach, both machines for bulk excavation and manual finishing for precision is being done. So in urban setting areas with utility concerns, hydro excavation using pressurized water and vacuum systems might be employed for sensitive sections of the excavation. Maintaining slope and support. So this is most important while you do digging for the foundation excavation. So proper sloping techniques must be used for excavation. For excavation sites are cut at angles determined by soil type to prevent collapse. Sandy soils typically requires greater slopes or flattened, while cohesive clays may allow slopes cuts more than 1 is to 2 to 1 is to 3. So slope design considers both short-term suitability during construction and long-term performance. And then if the digging is deep, then you have to use shoring system to support the excavated soil. So for deep excavations or where space contains preserving sloping, engineered support systems are installed. These include timber shoring, steel sheet piling, and other equipment, other things which are used for property trench box systems such as property trench systems. So these ports are progressively installed at excavation as the excavation deepens. And then you may use instead of shoring systems, you may use benching approach. So what is benching approach? So in benching approach, we create a slow step-like configuration. So in excavation sites, combining vertical cuts with horizontal surfaces. The technique provides stable working platforms while reducing the overall footprint compared to the continuous slope. So bench height and width are designed based upon the soil properties. So regular inspection of slope and support system is critical, especially after rainfall, vibrations from the nearby construction, or when excavation exceeds 1.5 meter in depth. So documentation of a site's support system is very essential, and daily safety check are standard practice on well managed construction sites. Next is you know construction at every point or every process you need safety, and similarly in this case of excavation you have to maintain safety measures. So with these safety measures are not only for physical protection. You need safety measures for physical protection, atmospheric protection, and you have to provide access management. So foundation excavation present numerous hazards that require comprehensive safety protocols. These measures protect workers, site visitors, and adjacent properties while ensuring regulatory compliance. So first thing you should know is how to do physical protection. So physical protection systems are mandatory barricadings with the high visibility tape or fencing surrounding the excavation perimeter. Clear warning signage communicates hazards of to all site personnel for excavation deeper than 1.5 meter. Hard barricades and fall protection systems become necessary. And for atmospheric monitoring, so in case of deep excavation, it requires testing for hazardous gases like methane, hydrogen sulfide, or low oxygen level before each shift. So ventilation systems maintain safe breathing conditions, particularly in confined excavation or areas with poor air circulation. And then for access management, you have to make certain arrangements. So safe entry and exit routes are established with proper ladders, ramps, or stairways spaced at a maximum of 25-meter intervals. These access points are kept clear at all times and are designed to facilitate emergency evacuations if necessary. So additional safety practices include daily inspection by competent persons, continuous monitoring for signs of potential collapse, keeping heavy equipment away from excavation edges, and comprehensive emergency response planning. When excavation exceeds 6 meters in depth or involves unusual hazards, special engineering oversight is typically required. Next is dewatering during excavation. Means during excavation you may have to do dewatering. So how it is? So for dewatering process, first of all you need groundwater assessment. So before excavation begins, the groundwater table level is determined through soil investigations and test pits. This information helps engineers anticipate dewatering needs, if any, and select appropriate methods. Seasonal variations in groundwater levels are also considered in planning phase. So after you have assessed the groundwater level, then you have to decide about the process of dewatering. So when the groundwater is encountered, active dewatering becomes necessary. So methods include open pumping from the sumps, well point system, deep wells with submersible pumps, or electro osmosis for clay soils. For extensive projects, a combination of techniques may be employed simultaneously if necessary. For all these things, water management is very important. So extracted water must be properly managed through diversion channels, settlement tanks to remove sediment, and controlled discharge to approved locations. Environmental regulations often govern water disposal, requiring permits and water quality monitoring before it is released. So effective down dewatering is critical for several reasons. Beyond enabling construction work, it improves soil stability, prevents bottom heave in deep excavation, and reduces lateral pressure on shoring systems. Continuous operation of dewatering system is typically necessary until foundation construction reaches a stage where it can resist hydrostatic pressure. So in environmentally sensitive areas, additional measures like recharge wells may be required to prevent groundwater settlement in adjacent properties due to lowered groundwater levels. Monitoring wells are well installed to track the effectiveness of dewatering operations. Next is measuring excavation work, how the quantity of earthwork to be excavated in foundation is excavated. So basically we do volumetric calculations. So in volumetric calculations you you need three things: length, width and depth. So accurate quantity estimation of excavated material is essential for project budgeting, contractor payment, and resource planning. The basic formula for calculating excavation volume is length. Volume, you know, it is equals to length into width into depth. For rectangular trenches, this straightforward calculation works well, but for irregular shapes, the equation typically divides into simple geometric sections and calculated separately, and then they are summed together to calculate the total volume at volume. So for these exact or more accurate calculation, you need to follow certain measurement protocols. So dimensions are recorded based on excavation drawings and verified through field measurements. The standard practice involves measuring the outer faces of the concrete for foundation trenches. So the measurement also include working spaces allowed where specified, and it counting for slope sides in volume calculation. So maybe we have to apply appropriate bulking factors for different types soil types. So these things are very important while you do calculation work for measuring work for calculation of quantity estimation of excavated work. So there are certain advanced methods of measurement for complex sizes. More sophisticated approaches may be employed. First method is grid method. So in this method, site is divided into grids. Depth measurements is taken at the intersections. Then you may use contour method. You know in surveying what is contour. So the point of equal elevation, they are called contours. So in contour methods, volume is calculated between pre-excavation and post-excavation contour maps. Then cross-section method, so series of parallel sections measured and then the average is taken. And then in today's scenario, when digital platforms are available, you may use digital digital train modeling. So computer based comparison of 3D surface models. With the help of that you can do all these things. So modern construction often utilizes drone surveys or laser scanning to create precise digital models for volume calculation, especially for large and complex excavations. So now we will take an example that will make the things clear that how the excavation quantity is calculated. Now let us suppose that trench length is 10 meter, trench width is 1 meter, trench depth is 1.5 meter. So trench length means the made length of the foundation trench along its center line. So see here, you have to calculate where the length along its center line. Then trench width, this is the design width including space for formwork. Then depth means the vertical distance from the ground level to the excavation bottom. So total volume is 15 meter cube. So the calculated volume of the excavated material. So additional consideration for working space allows you have to make certain adjustments. So in practice, excavation often includes additional width beyond the foundation dimensions to provide working space for formwork, waterproofing, and other activities. Typically, an area of 0.6 meter on each side is added to the foundation width for trenches deeper than 1.5 meter. So in another example, if we include 0.6 meter working space on each side, adjusted width will be 1 meter plus 2 into 0.6 meter means 0.6 meter on both sides. So the width, which is 1 meter, it will be taken as 2.2 meter, and adjusted volume will be 10 meter length, 2.2 meter width, and 1.5 meter depth. Of actual calculated adjusted volume will be 33 cubic meter, which was 15 cubic meter if we do not take into consideration the working space. And then in case of side slope calculation, if the excavation is not at rectangle 90 degree, it is on a slope, then what we do for trenches with side slopes common in deeper excavation, the volume calculation becomes more complex. Then here we use a trapezoidal formula. For that, volume is calculated length and width. There will, for length and depth there will not be any difference. The difference will be in width at the top and width at the bottom, and you take the average of both width at the top plus width at the bottom divided by 2. That will give you the average depth at top and bottom. So in our example, let us suppose the trench has a side slopes of 1:1 ratio. So width at the top will be, so width at the top, see if it is 1:1, see here, width at the top will be more than the width at the bottom. See here, slope is 1:1 means the width at the bottom is 1 meter and slope is 1:1 means depth is 1.5 meter. So it will be 1.5 meter on both the sides, 1.5 on this side and 1.5 on this side. So the total width at the top plus 1 meter, this rectangular portion, so total depth will be 4 meter. And the volume will becomes 10 meter into 4 meter plus 1 meter. You take the average of that multiplied by 1.5 meter, so the total volume becomes 37.5 meter. So this is how the quantity is calculated at a particular location. Next is methods to reduce and monitor errors. You know, you have to employ certain methods to reduce and monitor errors, because you know, even if you have small measurement errors in foundation excavation calculations, it can result in significant volume discrepancies, which leads to cost overruns and potential disputes. So implementing systematic error reduction strategies is essential for accurate quantity estimation. So for this, you can employ various methods. First one is cross verification protocols. So for this, you for the measurements to be made accurately and reduce errors, what you can do, you can employ a number of teams which can monitor and measure the excavation measurements. So measurements should be independently verified by different team members using different equipments. Site sketches are created to document the actual excavation shape and dimensions, with multiple reference points established to ensure consistency in measurements. And you can employ benchmark monitoring. So regular checkup against the established site benchmarks prevents cumulative errors. So in large excavations, intermediate benchmarks may be established at different key points to maintain accuracy. And today's scenario, digital level with the data recording capabilities help to eliminate human reading errors. And most important is, for all these things you required continuous supervision and documentation. So qualified engineers should be employed who should supervise critical measurement and approve quantity calculations. Detailed documentation with dated photographs at various stages of excavation provides visual evidence of progress and conditions, which can be invaluable for resolving disputes. So modern error reduction methods include technologies like GPS guided excavation equipment, which can work to millimeters per season, and real-time monitoring systems that alert operators while digging approaches design boundaries. So for projects with complex geometry, you can use 3D modeling softwares which can generate precise volume calculations by comparing pre-construction and as-built terrain models. Now we will discuss about the CPWD rates for foundation excavation. So different rates are being applied for different types of soil, for ordinary hard soil, and soft or decomposed soil, the rocks. Different rates are employed. For ordinary soil, standard rate is 250 to 350 per cubic meter as on 2024. So it applies to typically loamy and sandy soils excavated to moderate depths. And in case of hard soil rate of 400 to 500 per cubic meter as on 2024 is applied. So it is applied to soft clay, muram or soil with small boulders requiring picks. And for soft and decomposed rock, standard rate of 650 to 800 per cubic meter is uh, used. So it requires pneumatic tools for limited blasting, including weathered rocks. So for that, you have to use this rate. So we can say that 100% rate we will assume the 100% rate as 650 to 800, and in case of hard soil, the rate is approximately 85%, and for ordinary rate soil, the rate is approximately 70%. The Central Public Works Department has published a comprehensive schedule of rates that serve as a standard reference for the government projects and is widely adopted by the private sector construction as well. These rates are revised periodically to reflect changes in labor cost, equipment rates, and material prices. The CPWD rates include not just the cost of excavation, it also include loading and initial lead up to 50 meters and unloading. These three things are already added in this rate. For this, if the distance is more than 50 meters, or additional cost may be applied for disposal beyond this initial lead of 50 meters. So the rates also vary based upon the depth ranges, with the premium rates applied to the excavation below 2 meters due to increased difficulty and safety requirements. Well, now we will discuss about, as we have already discussed, the things which affect the excavation rate. So we will now discuss in this slide in details the different factors which may affect the excavation rates. First is soil type. So the nature of soil significantly impacts excavation difficulty and cost. So sandy soils are easiest to excavate, while the rocky terrain requires specialized equipment and techniques, potentially increasing the cost by 200 to 300%. And then excavation depth. So as the depth increases, the rate also increases. So deeper excavation involves additional challenges, including access, material removal, safety requirements, and potential groundwater issues. The CPWD rates typically increase by 20% for depth beyond 2 meter and 40% by if the depth is more than 3 meters. And it also depends upon the site locations. Urban sites typically commands premium rates due to restricted working hours, traffic management requirements, and limited space for equipment and material staging. So remote locations may also incur higher mobilization costs and labor premiums. And then the method of excavation also affect the rate of excavation. So the choices between manual labor and mechanical excavation affects both cost and timeline. Machine excavation is 70 to 80% more efficient, but it requires access for the equipment and may not be suitable for precise or confined work. And then disposal rate distance. So as we have already discussed that disposal up to 50 meter has been included in the rates. If the transportation cost for excavated material increases with the disposal distance. So CPWD rates, it includes initial bleed of 50 meter with additional charges per kilometer. Beyond this will be added. So urban projects often face higher disposal costs due to limited nearby dumping options. And then if there is dewatering requirements, the presence of groundwater can increase the cost by 30 to 50% due to pumping equipment, maintenance of dry condition, and reduced productivity. So continuous dry watering operations requires additional labor, fuel, and monitoring. So in the end, we can conclude and we will discuss about the best practices. The key things which you must take in mind while calculation of foundation excavation and various processes of foundation excavation. You should remember that foundation excavation represents a critical phase that sets the trajectory of construction quality, safety, and project economics. The integration of careful planning, precise execution, accurate measurements, and standard costing creates foundation for project success in both literal and figurative terms. So best practices for foundation excavation include thorough pre-excavation planning and comprehensive site investigation, precise layout and continuous verification against design documents, layered excavation with appropriate slopes and support systems, rigorous safety protocols and continuous monitoring, systematic measurements and documentation of quantities, reference to standardized rate like CPWD, and appropriate adjustment. So these are the best practices you should follow as far as excavation of foundation is concerned. And now it is in the present scenario. As the construction technology advances, foundation excavation continues to evolve with the innovatives of innovations of GPS guided equipment, ground penetrating radar for surface mapping, and digital twin modeling for more precise quantity estimation. So, for project stakeholders, understanding the nuisance of foundation excavation, quantity estimation, methods, and CPWD rate application provides a solid basis for more accurate project budgeting and scheduling, reduced dispute over excavation quantities, better risk management for unforeseen ground conditions, improved compliance with safety and environmental regulations, enhanced quality control throughout the construction process. So this is all about the excavation and foundation. Uh, Thank you all for watching this video. Have a nice day.